This lesson is about graphing reciprocal functions. To begin with a definition, a reciprocal function of f of x is written 1 divided by f of x, or 1 over f of x. So what we're doing is taking y values, because that's what f of x is, and we're considering their reciprocal. I'd like to start by looking at a graph image with you. If I have the graph x minus 1, which is a line, I'm going to find the reciprocal of this function. Enter 1 divided by, and I'm going to refer to y1. So what this is effectively doing is 1 over x minus 1. Now, I'm also going to make this graph bold because I want to make it stand out in comparison. I'm going to graph both the line and its reciprocal. I'm choosing Zoom 4 window. Try to choose Zoom 4 window. There we go. And we see the line. And this is what the reciprocal function looks like. Now, the reciprocal function is a type of rational function. It has some special properties, though. Notice, first of all, the intersection. Y value of negative 1, y value of positive 1. See, the reciprocal, consider all the y values of this line. The reciprocal of the y value of 1 is 1. That's why the reciprocal function passes through this point. The same is true here. On the line, y is negative 1, where my cursor is. The reciprocal of negative 1 is also 1. Now notice 0. The line has an x-intercept here. The y value is 0. The reciprocal of 0 means 1 divided by 0. And therefore, I get a vertical asymptote here. Another important feature. A couple of other points I want you to notice. When the original function has a y value of 2, the reciprocal will be 1 over 2. Notice how this is graphed at half a unit up. The same will be true for negative 2. Over here, y is negative 2. The reciprocal then is negative 1/2. I'm not changing the x values. This is all about given y values for an x value. So all of my movements are up or down, meaning the x values aren't changing. One more thing. On the line, the y value right here is 1/2. The reciprocal of 1/2, 1 over 1/2, is 2. And basically this is how you'd go about graphing reciprocal functions if you weren't using a graphing calculator. So let's work through an example now. Just want to recall, we want to think of convenient y values for f of x because f of x means y. Think of 0, 1, negative 1, 2 and negative 2, half and negative half. Write the reciprocal, plot the results. I've got a table set up and I've got an image of f of x set up here. We're going to work with this. So, the y value is 1, right here. That's when the x is negative 2. What's the reciprocal of 1? Well, 1 over 1 is 1. So, I'm going to plot a dot at the same point as I had on the original function. This is called invariant. It does not vary. Negative 1. There's a negative 1, and there's a negative 1. It occurs twice. It occurs when x is 0 and negative 4. Negative 4, 0. The reciprocal of the y value is negative 1. Again, it's invariant, so I'm going to plot nice big dots right there. Those ones don't change. Where's the function half? Right here and right here. The reciprocal of half is going to be 2. Notice how I moved my cursor directly up or down from where I was. 1 over 1 over 2 is 2. And it looks like it happens at negative 1.5 and negative 2.5. Okay, negative half. Well, here's a negative 1/2 value. That's at x equals negative half. And here's one at x equals negative 3.5. The x values that I'm writing in this list aren't particularly important. I'm just putting them there for completeness sake. So 1 over negative 1 over 2, well, that's negative 2. So I'm going to go directly down to negative 2, directly down to negative 2. There we go. Negative 2 values for y. Well, that happens right here at x equals 1 and at x equals negative 5. The reciprocal of that is negative 1/2. So I'll move my cursor from -2 directly up to -1/2. -2 directly up to -1/2, right where that number is. And there's one other thing I want to do that I didn't put in the list. Where is f of x 0? A very important consideration. Well, here's a 0. What's 1 over 0? Well, you can't divide by 0. This is called an undefined number. It's undefined as a real number. Happens at -1 and at -3. How do I plot undefined values? Well, vertical asymptotes. So here I go making some dotted lines that pass through the zeros on the function. Okay, it's a little sloppy there, I'll fix that. Alright, now all that remains to do is to connect all of these dots with a smooth curve heading toward the asymptotes. So this one goes through these 3 points and curves like that. Make little arrowheads. I'm going to connect these 3 points like this. Put some arrowheads there. And these 3 points like that. Now, I didn't comment about this area here. The arrowhead means keep going, and these values are large negative values. If we think of the reciprocal of a large value, I get a very small value. That's why I know it's asymptotic. That's the basic idea of how to graph these. I've got some other examples for you to work on right down here, and maybe you can push pause, try these ones out, and then push play again, and you can observe my results. Welcome back. I finished the first one for you, and I want to make a few observations. This is the completed graph of the reciprocal function 1 over f of x. What I did was I looked where the zeros were, right here, and I plotted vertical asymptotes because we are writing 1 over 0 to do the reciprocal. I look at the invariant point 1. 1 over 1 is still 1. -1. 1 over -1 is still -1. These ones do not vary. The other points I plotted were 1/2, which became 2, and -1/2, here and here, which became -2. And I connected the dots. Push pause, try the next two, and then check your work. Okay, we're back, and I finished the other two. I'd like to make an observation about the first and the third graph. The first and the third graph have endpoints, here and here, and here and here. If there are endpoints on f of x, then 1 over f of x, the reciprocal, should not extend. So make sure you have a dot here and a dot here, and that you don't carry it on beyond that, because there was no f of x at that place. This graph, I looked at the peaks and the valleys as well. You look at extreme values, and if you just study that, I hope that makes sense to you and you can see where I got everything. I want to do one more thing with you, and that's this. How do I graph f of x if I'm given 1 over f of x? Well, the process is really the same, because 1 over f of x is f of x. So if I want a reciprocal of a reciprocal, the effects cancel. So we're really doing the same thing. Here's a graph of 1 over f of x. And we will do the exact same process to try to generate f of x. I'm not even going to bother writing the x values here. They're not particularly important. The reciprocal of half is 2. The reciprocal of -1/2, -2. The reciprocal of 2 is half. -2 makes -1/2. 1 and -1 are my invariant points, and 0 will be undefined. Now here's something new. Undefined. Undefined means I was dividing by 0. So if I had number divided by 0, the reciprocal is 0 divided by number. See the relationship between 0 and undefined. 0 produce undefined reciprocals, undefined produce 0 reciprocals. Looking at this graph, you can see a vertical asymptote. That means it's undefined there. That means f of x is 0 there. Look where this graph has a value of 1. My graph will be invariant and therefore also pass through that place. Same with -1. Looking for 2, I would plot half. -2, I'd plot -1/2. At half, right about here, I would plot a 2. And at half, I would plot 2. What we can see is a line is forming in this case. I should have used a ruler. But there's the reciprocal of that reciprocal graph. Now, Not every reciprocal of reciprocal produces a line, but this one did. That's the lesson. Enjoy the practice.